Have you ever typed exactly what you want into a search bar, hit enter, and watched the screen return 0 results? You know the store sells it, you've seen it, but the site just shrugs. Sarah Chen, a data analyst at North Star Retail, sees this happen all the time. On a Monday morning, she checks the logs and spots a frustrated customer searching for a blue summer dress. Sarah checks the back-end database. North Star has 10 different dresses that perfectly match that description in stock. Yet for this shopper, the search engine returned absolutely nothing. The problem is the wording. The catalog describes the best match as a lightweight floral frock. The user searched for dress. When the search bar requires an exact spelling match instead of understanding what the shopper actually means, the user leaves and the business loses the sale. This failure comes from an old standard algorithm called a bag of words model. To this legacy system, text consists of isolated characters. Words are treated as literal identity codes, with no context or relationship to the vocabulary surrounding them. Because it only checks for matching letters, a query for dress will never trigger a result containing frock. This mapping illustrates a problem known as one-hot equidistance. Mathematically, because they share no letters, the system views the word frock as exactly as unrelated to dress as it is to the word spaceship. Relying strictly on character matching fails because human vocabulary is messy. People use dozens of different words to describe the exact same concept. The modern solution discards spelling. Instead of matching letters, we translate the text into numbers using a process called embeddings. By tracking which words frequently appear next to each other across billions of sentences, a pre-trained AI model learns a rule. Words used in similar contexts share similar meanings. We run the entire retail catalog through this model. It reads every product description and translates each item into a dense coordinate, specifically a point plotted across 384 distinct mathematical dimensions. This multidimensional map shows a completely different structure. Words like dress, frock, and sundress physically group together in overlapping neighborhoods based on context. These clusters map the actual concept of the item. Spelling no longer matters. Location in the data does. By turning vocabulary into multidimensional geometry, computers finally have a way to process abstract human thoughts as measurable numerical data. Let's return to the failed query. When the customer types blue summer dress, the system instantly translates that phrase into its own set of numerical coordinates and drops it into the exact same vector space. To find a match, the system uses a formula called cosine similarity. This measures the distance between the search query's new coordinate and all existing catalog coordinates. We calculate the precise geometric angle between the user's query and the floral frock data point, giving us a ranking of spatial closeness. Because the locations of summer dress and floral frock heavily overlap, the system immediately pulls the correct item to the top. Semantic search rescues the transaction by evaluating the actual geography of meaning, rather than running a rigid checklist of letters. But this spatial map has a weakness. If a user searches for a hyper-specific product code, like P0042, semantic models often get confused trying to find the meaning of a random string of numbers. The industry standard solution in a production environment is to build a hybrid search engine that runs both systems at once. The labor is divided. The legacy keyword matching system, known as TF-IDF, is kept intact specifically to handle exact details, part numbers, and hard rules. While that handles the strict filters, the semantic embeddings run in parallel to catch the fluid, ambiguous searches driven by human intent. Enterprise AI succeeds by layering contextual understanding on top of strict, literal logic. Mapping language into numerical coordinates applies to every form of digital text, from legal briefs to casual conversation. Translating messy human vocabulary into multidimensional vectors is the foundational building block for all modern generative AI. Large language models like ChatGPT rely on this same underlying representation. This geometric map allows the AI to navigate the intent behind your prompt, locating the concept behind your query to provide an answer that matches your intent. By assigning spatial coordinates to words, we transitioned from matching letters to measuring meaning. This capability started with a better search bar and resulted in systems that can finally understand what we're trying to say.